Last lecture, we talked about pH and pOH. We also discussed that if your hydronium concentration is greater than 1 times 10 to the -7 molar, that you're going to get an acidic solution. If your hydroxide concentration is greater than 1 times 10 to the -7 molar, then you're going to get a basic solution. A low pH refers to an acidic solution, and a high pH greater than 7 refers to a basic solution. When your concentrations of your hydronium and your hydroxide are equal, and they're equal to 1 times 10 to the -7, you get a pH of 7, which is a neutral solution. So it's neither acidic or basic. We also talked about the water ionization constant, which is equal to 1 times 10 to the -14 when the temperature of your water is 25 degrees Celsius. And we said that Kw is equal to your hydronium concentration times your hydroxide concentration. Okay, so if we look at this carefully and we take the negative log of both sides, we'll get negative log of Kw is equal to negative log of your hydronium concentration times the negative log of your hydroxide concentration. Okay, so we're going to take the negative log of 1 times 10 to the -14, and that's going to equal negative log of your hydronium concentration plus the negative log of your hydroxide concentration. Okay, that's according to your rules for logarithms, that if you multiply them, it's actually, you're taking the summation of that product. And if you plug in your calculator the negative log of 1 times 10 to the -14, that's going to equal 14 is equal to, and we know that negative log of hydronium is equal to pH, and the negative log of your hydroxide is equal to pOH. So this is an important formula. 14 is equal to pH plus pOH. So this is another equation that you can use to derive either pH or pOH in some problems.